you will write an equation of a line that passes through a given point parallel to a given line, and you'll also write an equation of a line that passes through a given point perpendicular to a given line. So let's just figure out what these are. Parallel lines are lines in the same plane that never intersect, and what's very important about these is they have the same slope. Perpendicular lines are lines that meet to form right angles, and what's important about them is their slopes are opposite reciprocals of one another. Okay, so since that's kind of a hard concept to understand, let's just practice a couple here. If one of the lines has a slope of 2, the other would be the opposite, so that'd be negative, and the reciprocal, so that would be negative half. These are opposite reciprocals of one another. Let's try another one. If the slope is 1/4, then the slope of a perpendicular line would be the opposite, which would be negative, and the reciprocal, which would be 4, so negative 4. So opposite reciprocals of each other. Write the slope-intercept form of an equation for a line that passes through negative 3, 5 and is parallel to the graph y equals 2x minus 4. So since it's parallel to this line, we know the slope is 2. Think about that. How do I know that? Well, parallel means same slope. And if this is the one line, well, then this line has to have a slope of 2. So what would you like to use? Well, we want to write in slope-intercept form, but I don't know the y-intercept here. So what I'm going to do is you could either do like lesson 2 and use this and plug in values and solve for b. Or since I know a point and I know a slope, let's just use point-slope form. Let's just use that tool to get there. So I'm going to do y minus 5 is equal to 2 times x plus 3. Remember, because it's y minus y1 equals the slope times x minus x1. So to get this to solve for y, I'm going to distribute first. So it's y minus 5 is equal to 2x plus 6. And then I add 5, and I get y equals 2x plus 11. So you notice these two lines have the same slope, but they are going to go have different y-intercepts because they are two lines in the same plane, but they don't intersect. So this is how you would do a parallel example. So try one example in your notes. Now determine whether lines are perpendicular. So we're going to have to find slope of those line segments, and so we want to see if AC is perpendicular to BD. So if you'll notice AC here, if we want to find the slope of that, we would do 1 minus 5 over 7 minus 5. 1 minus 5 is negative 4. 7 minus 5 is 2. So the slope is negative 2. Now, if they're perpendicular, the other slope would be what? Think about it. Opposite, reciprocal. So let's see if it is in fact. So let's do BD now, which would be 0 minus 4 over 0 minus 8. So that would be negative 4 over negative 8, which simplifies to 1/2. So would you say these are perpendicular? Yes, these are, because this is the opposite reciprocal of one another. So you can test lines and see if they're parallel or perpendicular by checking slopes. Try the example in your notes. Now I have 3 graphs, y equals 5, 1, 2, 3, 4, 5. So that's going to be a horizontal line here. And then I have x equals 3, 1, 2, 3. That's going to be vertical here. And then I have y equals negative 2x plus 1. So 1 is here, and it's going to be a fall 2, run 1. Fall 2, run 1. And if I had a ruler, this would be a lot easier. But I don't have one, so I'm going to do the best I can with that. So of these 3 lines, I want to see if they're parallel or perpendicular. Well, just by visually looking at these, you can see that these 2 are going to be perpendicular, and you can check their slopes. One is going to be 0 over something, and one's going to be something over 0, and those are opposite reciprocals of each other. So you know for sure these are perpendicular. You're not going to have any parallels because none of these have the same slope. That's a slope of 0, that's an undefined slope, and that's a slope of negative 2. So you would just say that these 2 lines are perpendicular, but none are parallel. Write the slope-intercept form of an equation for a line that passes through negative 4, 6 and is perpendicular to this graph. Well, we need to figure out what the slope of this is first to find the perpendicular slope. So I think it'd be easiest to get this solved for y. So subtract 2x, and you have 3y is equal to negative 2x plus 12. Divide by 3, and you have y equals negative 2/3 x plus 4. So this is the slope of the line. The opposite reciprocal would be m equals positive 3 halves, right? Opposite reciprocal. So what I'm going to do is the same thing that I did in that first example. I am going to use point slope form because I have a point and a slope. So it's y minus 6 is equal to 3 halves x plus 4. I just used a point slope form. Now I'm going to distribute that 3 halves. So I have y minus 6 is equal to 3 halves x plus 3 halves of 4 would be 6. And then I'm going to add 6. And I get y equals 3 halves x plus 12. So this is the this is the slope-intercept form, which is what we wanted, of a line that is perpendicular to this line. So you could try the perpendicular example in your notes. Remember that parallel slope is the same, and that perpendicular slope is the opposite reciprocal. And remember, if you ever have any questions, just let me know.